Welcome to Math Shorts, tantalizing mathematical tidbits that will amaze, entertain, and delight. Math Shorts is brought to you by the Ottawa Zone for Mathematics Education. The Ottawa Zone for Mathematics Education is a chapter of the Ontario Association for Mathematics Education. Information about both organizations can be found in the information for this video. In this episode of Math Shorts, we're going to be looking at square roots. So, before we can look at square roots, we kind of have to understand what's going on and how this thing is defined. So, there's the word square in the name, so we're going to start with the square. So if I start with a square whose side length is s, then if we want to calculate the area, it's length times width, or s times s, or s to the exponent of 2, which we usually call s squared because it comes from the area of a square. And we're going to see that finding the square root of something is actually finding a relationship between the area of a square and its side length. So, for example, if we had the side length was 5 units long, then the area would be 5 times 5, or 5 squared, or 25 square units. And if we sort of write that relationship down here, if the side is 5, the area is going to be 25. And going from the side length of 5 to the area of 25, we're doing what's called squaring. So we would say that 25 is the square of 5. In other words, it's the area of a square of side length 5. Now what we're interested in is the opposite relation. If we start with the area and we want to find the side length, you probably have seen that symbol before, that radical sign. Radical 25 is 5, so going from 25 back to 5, we call that the square root. So we would say that 5 is the square root, or a square root of 25. Now, in order to get a better understanding of square roots, since it's tied with squares or perfect squares, perfect squares are pretty easy to understand, so we're going to look at them, get an idea of how they behave, and that'll give us an idea of how sort of that opposite operation behaves. So if I look at 1 squared, 2 squared, 3 squared, and so on, the squares of the positive integers, 1 squared is 1 times 1, which is 1. So squaring goes this way, so square rooting will go this way. So that means that the square root of 1 is just 1. 2 squared is 4, so going backwards, the square root of 4 should be 2. And similarly, if we work out the rest of them, we can work out the square roots, or the numbers that give us a square root that's a whole number. And one thing that you'll notice, if we look at these perfect squares, 1, 4, 9, 16, 25, and so on, as we go out, these things get spread further and further apart. So the square root of 1 is 1, the square root of 4 is 2. Well, what about the in-between numbers like 2, the square root of 2? Well, it's going to be something between 1 and 2. Now, if we go to a calculator, we can work this thing out, and it's a big, long, nasty decimal number. What we're going to be interested in this video is how could we work out or get an approximation for these square roots without having to go to a calculator. Now, you may sort of know the square root as a number that multiplies by itself to give you that number. So if we're thinking of the square root of 4, we'd say what number times itself gives us 4, and it's 2. So if I was dealing with what number times itself is 2, one way I could do it is just say, well, I know that 1 times 1 is 1, 2 times 2 is 4, so it's going to be between 1 and 2. So we could do some trial and error. What about 1.5? Multiply by itself. Oh, it's too big. Then try 1.4. Oh, it's a little too small. And just go like that. That's sort of a numeric way to think about the square root. We're just thinking about the operation. But we want to look at this from a geometric point of view. And to do that, we sort of have to think of those squares. And so that's what we're going to do next. Okay, so let's approximate the square root of 2. And to do this, we're going to use something that's similar to base 10 blocks, where I'm going to use these two squares that have been broken up into 100 chunks and let each of those represent 1. So again, if we think I'm doing the square root of 2, it means if I have a square that has area 2, how long is its side? So I'm going to take 2 units of area and try to build a square. So how do I do that? Well, I'll keep this one square fixed, and I'm going to start peeling this apart and building a bigger square. So if I pull a whole strip off of this guy, I can stick it over there. But if I'm going to have a square, it has to be the same length as width, so I'd have to pull up another strip and put it on top. So I can kind of do that, do 2 strips at a time, put one on the side, one on the top, get it wider and wider and wider and wider. And eventually I've used up all my strips. And now this thing is going to be 1.1, 2, 3, 4, 5, 1.5 units on each side. Now, unfortunately, we could see that I can't quite make a square that's 1.5 on the side because I've used up all of my 2 units of area and I can't quite fill in the whole square. So that tells us that the square root of 2 is less than 1.5. So let's take a strip off of each and back it off. And now we've got 1.4 on each side, and I've got this chunk in the middle. That's 4 little pieces by 4 little pieces. So let's take these strips and now break them up into the little blocks. So I need 4 times 4 or 16 blocks. Well, these 2 strips were 10 each, so there's 20 blocks. So I've got more than enough there. So if I take 16 blocks from there, I can fill up the square. So I can make a whole square that's 1.4 by 1.4, but I still have a little bit left over, which means that my square root of 2 has to be bigger than 1.4, because it can make a square of 1.4 and still have a bit more. So this gives us a fairly decent approximation. But if we want to sort of think a little bit further, we can go beyond what our blocks can actually do. If I think of this little square, it's 1/10 by 1/10. So its area is actually 1/100th. So I can imagine, well, instead of having something that's 1/10 by 1/10 with area of 100, I could have it 1 unit long and 1/100th of a unit wide. So this very, very narrow rectangle has the same area as that little square. And if I replace all 4 of the remaining squares with these little ones that are 1/100th of a unit wide, then I can go through the same process. I can take 2 of those, put 1 on the side and 1 up here. And if I look along the edge here, notice that these are 10 of the little blocks long. And I've got 1, 2, 3, 4, 5, 6, 7, 8. One of these would be more than enough to fill up the remaining bit to make a full square. So now this is going to be 1.41 units long, and I'd still have stuff left over, which means my square root of 2 is going to be bigger than 1.41. But if I take the remaining 2 and put them beside the others so that I'm going to the edge here, I'm now at 1.42, I don't have enough area to make the whole square. So the square root of 2 is between 1.41 and 1.42. And if we get more creative with our thinking and go back and make things even skinnier and break them up into pieces, I could kind of keep going and piecing this thing together. But that's as far as we'll take this look. Now, suppose we didn't have base 10 blocks. Let's look at a way that we can get a rough idea of how big square roots are without having to break things up into decimals. So again, we'll go to square root of 2. So we've got these 2 blocks, and I want to make a square out of all this area. So again, using the same sort of idea, I've got to take this green square, cut it up into chunks, pad the sides and the top with the same amount to build our new square. So if we look, this is 1 unit here, this is 1 unit here. I've got to do equal amounts on the top and the sides, so I can think, well, what if I take that green square and cut it in half? I can now take those 2 chunks, put 1 on the top and 1 on the side, and that will give us an approximation. But again, it doesn't quite fill things up, so I know that the square root of 2 is less than 1.5 or 1.5, just like we did before. Now, what if instead we said, well, if I cut this into 2 pieces, I won't have enough, so let's cut it into 1 more. I'll take 2 of those pieces and put them on the sides. I got a chunk in the middle. Well, this strip that I've got left is more than enough because it's the same width as this, but it's 1 unit long, which is way longer than this. So if I cut it so that it's 1 1/3 long, I've got more than enough to do things, and that'll give me an approximation. And if I wanted to go further, well, I could cut a chunk off here that's 1/3 long, fill that up, figure out how much I've got left, and then do the same sort of thing. Cut it into pieces and cut and fill and cut and fill, and we could sort of fine-tune our approximation. Well, let's look at this method with something other than the square root of 2. So let's look at square root of 13. So if we go through those square numbers that we had at the beginning, we know that 3 times 3 is 9, which is less than 13. 4 times 4 is 16, which is greater than 13. So I know that the square root of 13 is somewhere between 3 and 4. So if I take 13 square units, or 13 squares, I can take 9 of them and make a square that's 3 by 3, and I'm going to have 4 more left over. And again, I want to take this extra stuff and build a bigger square. Now, if we look, the square already has side length of 3. So I'm going to have to fill up 3 spots here and 3 spots there. With our square root of 2, we had to fill up 1 spot here and 1 spot there, so we cut things into 2 pieces. Well, here I've got to fill up 3 and 3. So what happens if we cut all of our chunks, our squares, into 6 pieces? Now, if we start with this square down here, I can take each of those 6 pieces, and each of them are going to fit into one of those slots there. Do the same thing with the next block, and the next block, and the next block. And we'll see that if I've got 3, and each of these are 1/6 in width, so I've got 3 and 4/6, I don't quite have enough to make a square that big. So the square root of 13 is less than 3 and 4/6, which is 3 2/3. But if we did the same thing as before and say, well, if I cut it into 6 pieces, I'm not going to have enough. But if I cut it into 7 so that each of these strips I had 1 more, well, I'd have more than enough. So even though the square root of 13 is less than 3 and 4/6, it's going to be bigger than 3 and 4/7. So that gives us a fairly decent, sort of rough approximation of what the square root of 13 is. And like I said, if you were ambitious, You could go with this one, figure out how much you need to fill here, work out your new area, and then do the same sort of thing again and again and again to get as rough or as good approximation as you want it. So let's use this geometric method to allow us to get a rough approximation for any square root. So suppose I wanted to find the square root of some number x, and I know that x is bigger than n squared for some number, but less than the next square number. So that I know that it's going to be n point something. So how can we approximate that? Well, we know it's n in a little bit. And if we imagine, again, thinking in terms of blocks, n squared means I'm going to have something that's n by n here. And I'm going to have some extra squares to fill over. So when I start filling in spots, I'm going to have to fill in n spots here and n spots there. So if I cut everything into 2n pieces, it's going to work. Well, what am I going to cut up? The extra stuff. What extra stuff do we have? It's the stuff that we have that's bigger than n squared. So in other words, x minus n squared. So if we think of our 13 example, 13 was between 3 squared and 4 squared. So when we looked at over here, I had 13 minus 3 squared, 13 minus 9, which was 4. We had those 4 extra squares. So this is going to be a little bit too big, but we saw that if we do exactly the same thing, but instead of dividing by 2n, we added one more piece to help fill that chunk at the top of our square, then that would be sort of more than enough. So I'm going to get an approximation between here. So let's look at an example of that. So if we wanted to approximate something like 92, we'd say, well, 9 squared is 81, which is less than 92. 10 squared is 100, which is bigger than 92. So the square root of 92 is going to be somewhere between 9 and 10. So we'd say, okay, how much extra do we have? Well, 92 minus 81 is 11, so I've got these 11 extra pieces. So I can make a square that's 9 by 9 that uses up 81. I've got 11 extra pieces. Since it's 9 by 9, I've got 9 plus 9, which is 18 extra spots. So I'm going to be 9 plus 11 over 18 is going to be too big because I won't be able to fill up the part at the beginning. But if I took one extra spot, one extra chunk for each one, 9 and 11 over 19 is going to be a little bit too small because I'll have stuff that's left over. And if we work these things out as decimals, we can actually see how good we are. The square root of 92 is actually 9.591. At the lower end, this is 9.578. At the upper end, this is 9.611. So we'd see we're pretty good. And actually, if we rounded all of these to one decimal place, I get 9.6, 9.6, 9.6. So rounded to one decimal place, this actually gives us a good result. I hope you enjoyed this episode of Math Shorts. If you enjoyed this topic, there's a bonus video that explores this idea in a little bit more depth, and there's a link to it in the description of the video. Tune in again next month for more episodes of Math Shorts, and until next time, keep playing with your mathematics.